Here we got 6 numbers 1 to 6 and we have to form 5-digit numbers which are divisible by 3 or by 4, not by 3 and 4. So this is the conditions for the question. So to solve the question, let's first find out how many numbers are divisible by 3, how many are divisible by 4, how many are divisible by both 3 and 4. The sum of the numbers from 1 to 6 adds up to 21. So from this, if we have to remove a number and the resulting 5 digits must add up to a multiple of 3, the number that we need to remove must either be 3 or 6. We will use this principle again and again while solving this question. There are two options for removing a number, and once you remove the two options, once we exercise the two options, the remaining numbers can now be arranged in 5 factorial ways. Hence, the total number of 5-digit numbers divisible by 3 is 240. If a number has to be divisible by 4, the last 3 digits, or rather last 2 digits, have to be either 12, 16, 24, 32, 36, 52, 56 or 64. Now there are 8 such cases as we see here. For each of these 8 cases, the first 3 digits can be arranged in 4p3 ways. Hence the total number of cases is 192. Now let's look at numbers that are divisible by both 3 and 4. If the last 2 digits are 1 and 2, the first 3 digits can be formed by either removing 3 or 6, which means there are two options that we can exercise for removal of a number, and the remaining 3 numbers can be arranged in 3 factorial ways. The same would be the case for the last 2 digits being 24 or being 52. Now suppose we have 1, 6 as the last 2 digits. Now while forming the first 3 digits, we necessarily will have to remove 3. So we have only one option that we can exercise for removal of a number, and the remaining 3 digits can be arranged in 3 factorial ways. The same logic holds true for each of the cases here. Now what about 36? 36 is a special case. If we include both 3 and 6 in the current number, the number that has to be removed cannot be either 3 and 6, and hence no such number exists which is both 3 and 6 and is also divisible by 3. Hence the total number of cases 0 here. If you add all these cases, there are 10 into 3 factorial or 60 possible cases. Now if we visualize this as a Venn diagram, we have numbers divisible by 3, there are 240 of them. Numbers divisible by 4, we got 192 of them. Numbers divisible by both 3 and 4, we got 60 of them. So for the required answer, we must completely remove the shaded region. Hence the total number of cases 240 plus 192 minus 2 times 60. We are doing 2 times 60 because we are removing it from this 240 as well as from 192. Hence, we'll have 312 as a required answer. This question could either be done as a part of round 1 or round 2, preferably round 2, because it takes a little longer time.